Welcome to today's video where we are going to discuss theoretical yield, percent yield, and how to calculate the percent yield if given the amount of product that we made in a real-life chemical reaction. So first, to define theoretical yield. Theoretical yield is simply defined as the calculated quantity of product that we should make if given a certain amount of reactant. Now, those of us who have spent any time in the lab understand and realize that oftentimes the amount of product that we make in a chemical reaction does not hardly ever match our theoretical yield. Factors that could affect our theoretical yield, or factors that could affect our actual yield, include impurities, include process issues, include many things that are involved in the steps in our chemical reaction. And in fact, this is an invaluable calculation for people who need to determine efficiency in, let's say, companies that are producing products so that they can become more efficient and have less waste. So the percent yield is a representation of how close our products are in a real-life chemical reaction compared to the theoretical yield. The equation for the percent yield is that of any percentage. I remind everybody that any percentage, the equation for any percentage, is simply parts over a whole. In this instance, the part is the actual yield, what we actually got in the lab, compared to the theoretical yield, what we should have gotten. These should be measured in either moles or grams. Usually mass is simplest, and then we're going to multiply both of those by 100 to give us our percentage. So in our sample problem below, we are posed with the problem where we perform a reaction between barium chloride and excess silver nitrate. Real quick, let's define excess. Excess is defined as a quantity that ensures that this will not limit our products. So if you're reading a problem or you are performing an experiment and you have excess of a particular reactant, all that tells you is that this will not be your limiting reactant. If we recall from our last video, the limiting reactant is the reactant that limits the amount of product that we can produce. The excess reactant is the reactant that has leftovers. If we have excess silver nitrate, that means we will have leftover silver nitrate. Okay, back to our problem. What is our percent yield if we actually produce 2.5 grams of silver chloride? All right, so here's our equation below. We were given in the problem an actual yield of 2.5 grams of silver chloride. We need to determine the theoretical yield. In order to do that, we know exactly how much barium chloride we started with. We know that we're not going to run out of silver nitrate, so we don't need to run any calculations on silver nitrate. So in order to get the mass of silver chloride that we should have produced, we're going to start with our mass of barium chloride. We're going to then convert to moles of barium chloride. Convert from moles of barium chloride to moles of silver chloride. Convert from moles of silver chloride to grams of silver chloride. All right, so in order to do that, we're going to start with our 2.23 grams of silver chloride. I'm sorry, barium chloride. And hop aboard the Plug and Chug Express. All right, so down below we need mass of barium chloride. So let's check our trusty dusty periodic table. I see that barium has a molar mass of 137.33. Chlorine has a molar mass of 35.45. We're going to multiply that by 2 because we have 2 of them. 35.45 times 2 plus 137.33 gives us 208.23 grams per mole. So we're going to put our molar mass below, 208.23 grams barium chloride per 1 mole barium chloride. Down below, we're now going to convert from moles to moles. For this, we need to determine our coefficients. So barium chloride has a coefficient of 1. We're converting to silver chloride. 2 moles AgCl. 1 mole AgCl has a mass of, let's check silver, 107.87. Chlorine, 35.45. Add those up. .32 grams per mole. 143.32 grams silver chloride. Again, our units, barium chloride, grams of barium chloride, moles of barium chloride, moles, and we're left with grams of silver chloride. So that just means we multiply across the rows and then divide. So we're going to type in 2.23 times 2 times 143.32. Divide that by 208.23. That means that we should have produced 3.07 grams silver chloride. All right, so that means our theoretical yield was 3.07 grams. Now again, for our equation, percent yield is our actual over our theoretical. So all we do is divide our 2.5 grams AgCl by our 3.07 AgCl times 100, which means that our percent yield is 2.5 divided by 3.07 times 100, 81.43 or 81.4% yield. And again, this is, excuse me, again, this is a means to represent the efficiency of your processes. Hope this is helpful. Enjoy.